In Activity 6, Bernoulli's principle, students observe the effect of velocity on air pressure. They first observe that air flowing around objects may cause the objects to behave in unexpected ways. Then they demonstrate the pressure drop in a fast-moving stream of air, and finally, students discover why the pressure exerted by moving air decreases the faster it flows. You will need the following materials from the kit: Activity Sheet 6 and a table tennis ball. You will also need to provide a pair of scissors, a handheld hairdryer, and sheets of plain paper. To prepare for the activity, make a copy of Activity Sheet 6 for each student. Cut sheets of paper lengthwise into quarters. You will need a hairdryer and a table tennis ball for a demonstration. Each team of 2 will need a paper strip. Locate a hallway at least 10 meters long where students can perform a class demonstration. To begin the activity, tell students that in order to understand how airplanes lift off the ground, they need to know more about the properties and behavior of air. Plug in a hairdryer and hold it so that its nozzle points toward the ceiling. With your other hand, position the table tennis ball above the hairdryer nozzle. Ask students, "What do you think will happen to the table tennis ball if I turn on this hairdryer?" Students will probably say that the ball will shoot up into the air and then fall to the ground. Accept all answers. Turn the hairdryer on high and gently release the table tennis ball. The ball should float on the stream of air coming from the hairdryer. Now ask, "What do you think will happen to the ball if I move the hairdryer?" Students may guess that the ball will fall when the hairdryer is moved. Move the hairdryer slowly to the right, then slowly back to the left. The ball should move with the hairdryer and appear to magically float in the air above the dryer. Explain that when air flows around objects, it can make those objects behave in unexpected ways. Give each student a copy of Activity Sheet 6. Divide the class into teams of 2 and hand out a paper strip to each team. Have students hold one end of the paper strip against their chin, just below their bottom lip, and let the other end of the strip hang down. Have students gently blow air across the top of the paper. Most students will be surprised to see the paper strip lift slightly. Then tell students to blow harder. Ask, "What happens to the paper when you blow air even harder?" Students will observe that the paper strip lifts higher and may begin to flutter. Tell students that an 18th century Swiss mathematician and physicist named Daniel Bernoulli first observed that whenever air flows, the pressure it exerts on the surfaces it flows past drops. According to Bernoulli's principle, when air is blown over the paper strip, the air starts to move faster, causing its pressure to drop. The still air below the strip is now at a higher pressure than the moving air above the strip. As a result of this difference in pressure, the paper gets pushed up or lifted. Divide the class into 3 groups. Tell students that each group is going to walk down the length of a wall, knocking on that wall once every second. One group will walk slowly while knocking, the next group will walk quickly, and the third group will run. Students will then compare the number of knocks each group made as it moved along the wall. It is important that the knocks are made at the same interval for every group and that students count the number of knocks. After all 3 groups are finished, ask students, which group traveled fastest? Which group traveled slowest? The group that ran, Group 3, was the fastest. The group that walked slowly, Group 1, was the slowest. Further elicit that Group 1 made the most knocks and Group 3 made the fewest knocks. Then ask, what can you conclude from this? Students can conclude that the faster they travel, the fewer knocks they make. Tell students that every knock represents pressure exerted by a molecule bumping into an object. Guide students to understand that the molecules that were moving slowest exerted the most pressure. Conversely, the molecules that were traveling fastest exerted the least amount of pressure. Then, have students complete their activity sheets. Next, turn on the hairdryer again and float the table tennis ball in the airstream above the dryer. Challenge students to apply what they have just learned by asking, "Can you use Bernoulli's principle to explain why the ball behaves the way it does?" Help students conclude that the air moves fastest in the center of the airstream, so here the pressure is lowest. If the ball drifts to one side, it gets pushed back to the middle by the higher pressure of the slower-moving air at the edges of the airstream. Finally, inform students that in the next activity, airfoils, they model airplane wings and investigate how the wings help a plane lift into the air. To conclude the activity, Tell students they can keep the paper strips and use them for bookmarks. Return the table tennis ball to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.